Today we'd like to introduce Schímatos, which is a resource that can be used to create and edit linked data using forms that are generated from SHACL constraints. The primary motivation for developing this tool is to create an interface with which users that have less experience with RDF or linked data can edit these triples in a more hierarchical and intuitive manner. So this tool can either be downloaded and run locally, and it will interface with SHACL endpoints at a given URL, or it can be accessed through our website at schematos.github.io. At present, Schímatos allows you to interact with and update any data that is made available through a SHACL endpoint. And we can specify that in our settings by setting the triple store that we want to access, the location of the SHACL files that we want to use for our forms in the tool, and we also have other settings available. In this demo, we'll discuss how to update information about an entity called Sergio that's within our data graph, and we'll do that using a human form generated from a SHACL constraint using Schímatos. So looking at our UML diagram, we can see that when we search for a particular entity using this string, we'll run this query over our triple store located on an external server to collect the relevant subjects. There are options to fine-tune by whether you want to go label or other variations, but in this case we're just going to go for any object that contains the string Sergio. And we can see we've got this set of options here from our triple store. We've added the labels instead of putting the IRI here, so users can see what is actually going on. And we generate on the side here a bit of information about this entity. So we can see we've got that they're a researcher, that they've got this parent, that they're from the Australian National University, and they've got a publication listed under their name as well. So that allows us to verify that this is the particular entity we want to edit. And now that we've done that, we can choose which form we want to apply. So when we do this particular step, we'll be running a search over our SHACL graph. That graph may be located in the same triple store as our data, or it may be located in a different triple store. That's entirely up to users' settings as to where that comes from. And then we'll run this query to extract the SHACL shape, and we can do that now. So we'll see that we've actually got two options here. The bottom option has been put in by us as a direct translation from the SHEX constraint that's provided by Wikidata. There's also another shape here, which appears to have been uploaded by another user that wanted to create their own Wikidata shape. So we're going to use this translation from the SHEX shape, and we can see now that we have a few options about how we want to apply this selected shape. So we can see that in addition to our selection of which shape to use, we can select by severity levels. So severity levels are within the definition of the shape itself. For each property, we expect that either there'll be a specified severity level of that constraint, being info, warning, or violation, or if that severity isn't specified, we take it to be a violation level severity. And using those pieces of information, users can select which property fields from the SHACL constraint they want to generate their form. So by default, we use the warning and violation properties. Info can also be applied, but for most users, these settings are fairly apt. And we're now generating our form. So the primary form comes from the node shape, and then each of these individual fields is generated from a property shape within our SHACL constraint. We can see that some of these fields are colored in green. Those are fields which pass the validation criterion. So in the cases of these three, that would indicate that the min count for these property fields is 0, so they're automatically satisfied. Whereas for these red boxes, we're going to have a min count of 1, so we actually need to input data for them to pass the validation constraints. In the case of gender, that has an in property, which means that only these 6 options can be used to satisfy this particular field. So we're going to select the option male, and then we can now come down to date of birth. This date of birth field has been customized based on a pattern constraint provided. So we're just going to input a date here and submit that. And now we'll come down to place of birth. We can see that Schímatos actually provides some options for us here. These options come from existing objects of this place of birth predicate that are in the graph. So one option is Canberra, and because the label for that object is also in the graph, we display the label. There's also this particular entity, but it doesn't have a label within the graph, so we just give the IRI instead. So we're going to select Canberra, and now we've satisfied our place of birth for city. In terms of country, it appears there's no values within the graph yet. So what we're going to do is just manually enter the identifier for Australia, which is WDQ408, and we can submit that like that. Now, the other thing I want to show you is how Schímatos handles nested shapes. So within the human shape, if you've got mother, father, sibling, or any of those other human entities that satisfy a property field, then this is actually a recursive shape because they must also satisfy the human shape property. And we can see that if we enter this mother field. So we're now going to enter Sergio mother, put that into our form, and now that we've got all this data ready to go to be submitted into our triple store, we can choose to select all this data. We can see that it's now in the triple store, and in this mother field, it's taking a little while longer to load because it now has to create a new form, a new nested form, in which the form for mother can be filled out. Alright, so we can see that this is another human shape within here. We know no information about this mother as of yet, so it's all empty, ready to go, clean form, and users can choose to work with this as well. So because of this nested structure that Schímatos allows you to have, we also allow you to navigate through the form a little bit so that you can refocus on particular entities that you might be interested in filling information in about. So say we want to just focus on filling out information about Sergio mother, we can now select on this button here and choose to focus on this target. And we can now see that we've just got this form about the mother that we can work with. So now we're going to go through the process of creating forms in Schímatos, which is the same as creating SHACL constraints because there's a mapping between the two within the tool. So what we're going to do is we're first going to merge the human shape and the university shape. The university shape applies to university professors or lecturers and has specific details such as which university they go to, but doesn't contain information more generally, such as their family, their address, date of birth. And we want to encapsulate all that information into a single shape. So we're going to merge these two shapes. And then after that, we'll also add an additional property manually. So first of all, let's go and collect our human shape. Let that load from our triple store. And we can select that. And now instead of applying this, I'm now going to search for the university shape. And now that that's loaded, we can select Wikidata University Teacher. And I can see that I've now got these two SHACLs ready to apply. And I can apply both of those simultaneously. Like in the data creation example, I could toggle whether I want to add the information properties or not, and I can toggle these warning and violation properties, but I'll keep these as is for now and apply them. And now what Schímatos is doing is it's actually merging these two shapes to create the strictest shape possible. So if there's overlapping property fields, it will take whichever property field is most strict, and otherwise it will just produce the union of all the different properties. And we can see now that this is indeed different to the human shape we had before, because we have this employer field, we have university, we have things like publishing languages and occupation, which weren't present in the previous shape. Now, suppose that I wanted to also add the ORCID ID for this researcher. What I can now do is manually add this property constraint or this field into the form. So the first thing we're going to do is specify the predicate that will be associated with this property, and that from Wikidata is WDT P496, and that's just going to be a normal path. We could also have all these other kinds of paths such as inverse path or alternative path, but normal path is what we want. We'll keep this at a violation level of severity. We're going to specify that they can have at most one ORCID ID. We'll leave the message for now, and we also want to add another couple of constraints. The first is that we want the name to just be ORCID, and the second thing that I'm going to add is a data type. And within this data type, I'm going to specify TP ORCID. Now what I'm doing here is I've actually got a reference to a type store. And a type store is something we've created for Schímatos that creates a property shape constraint for a particular data type. In the case of an ORCID ID, that is just going to specify that the ORCID ID has to be a string that follows a particular regular expression. So now that I've entered this information, what we can do is submit this, and we can see we've now got this ORCID ID field, and it's got the correct structure for an ORCID ID. Now that we've done this, we can note that we've got a corresponding SHACL file that's been generated from this form, and in that file we've got all of the relevant information to that shape. We've got all the different properties that have been merged together. So we could download that to our own file. We can submit that back to the triple store, making sure that we've specified the name that we want. For example, new researcher. And that's how we create a new shape. We've been through some examples. Let's just have a look at the MVC architecture for the tool. So our model is just the data that is being used to generate our forms and to fill our forms. They come in the form of triple stores with a SHACL endpoint. They do not have to be located on the same server as Schímatos. In fact, Schímatos can be run locally. And the SHACLs and the data don't have to be on the same server either. They are just input by the users as a URL. To note, ANU is going to be setting up a SHACL store under the domain name shacl.kg, where we'll store a variety of SHACLs, some of which have been manually created, some of which have been learnt, and hopefully this will be one of the SHACL stores that is accessed by many versions of Schímatos to enable a wider variety of forms to be available. So then whenever we're using the tool, for instance, displaying a form, updating details, doing what we want to do, our controller will query this model to obtain the data, to obtain the SHACL constraints, and then generate the form using these mappings, create a form display, and that is then displayed to our end users.